What up, calculus students? It's Mr. Mester coming at you with your first homework video. This is actually the second time I've done this homework video because I think I could have done a better job than I did the first time. This is what I provide for you guys, and I hope you guys utilize these not to copy down, but just to help you understand or to check your work. And this first lesson we'll call lesson 0 because it's just something that we kind of have to know. It's not really calculus content. However, it is something that you will be required to know for our calculus class. It's trigonometry in the unit circle. And we talked about in class how I never was able to memorize things well. And this was a topic where I thought maybe I'm bad at math because I just don't I can't memorize the unit circle. Then I discovered you could do this without the creation of the unit circle. And our challenge for this class, so that we memorize less and understand more, is to do these problems without the creation of the unit circle, to understand why the cosine of pi over 4 is root 2 over 2. And there's a couple things that are not new to us and a couple things that are new to us. And we talked about how what should not have been new to us is if I say, hey, this is a 60 degree, 30, 60, 90 triangle with a 6-degree base angle. What are the side lengths of a 60-degree angle? Angled right triangle. And what should not have been new to us is the fact that the hypotenuse could be 1. The longer side is root 3 over 2, and the shorter side is 1/2. Then just orient that differently so that it's 30 degrees as a base angle, and we just kind of put the longer side on the adjacent side. That's better. If this was 30 degrees and this hypotenuse is 1, well then just our side lengths would flip, where the root 3 over 2 longer, because root 3 is bigger than 1, goes on the bottom. And then you should know the side lengths of a 45, 45, 90 triangle with a hypotenuse of 1. This is a 45-degree triangle. And that's root 2 over 2. And root 2 over 2. And cool, that's where we start. And then we talked about radians. Radians were new last year. And radians is just a different way of measuring around a circle. So it's like angle measurements. It's not an angle measurement, it's actually like an arc length. But we can think of it as angles. And we talked about how if a unit circle is a radius 1, then 360 degrees is 2 pi, which means 180 degrees is pi. And then the more important ones, 60 degrees is pi over 3. Take 180 and divide it by 3. You get 60. Pi divided by 3 is 60. So we can just kind of start with this and say, okay, this is pi over 3. This triangle is created with an arc of pi over 3. It creates a 60 degrees. So I'm going to say this is my pi over 3 triangle. If I divide this by 6, I get pi over 6, and 180 divided by 6 is 30. And I'm going to say this is my pi over 6 triangle. And then if I divide 180 by 4, it actually is 45. I'm going to say this is my pi over 4 triangle. Okay? Cool. So what I do myself is I actually think about triangles always with trigonometry because it's stuff that I've known. And then the one kind of other new thing besides radians is the fact that if, say, we have an angle and we create a triangle, the angle maybe is this obtuse angle 150 degrees or 5 pi over 6. Turns out we actually just have to worry about this angle created with the x-axis. It's called the reference angle. And a very important thing is that the trig function of an angle is equal to the trig function of this reference angle with the x-axis, or it's the trig of the triangle created with the x-axis. And keeping that in mind and keeping in the mind that this is a y-axis and an x-axis, we just have to understand to the right on the x-axis is positive, which means to the left would be negative. Up is positive, down would be negative. That allows us to find the cosine of pi over 4, not through memory, but through just understanding. Okay, if I went to pi over 4, that would be a 45-degree angle that I'm used to, creating a 45, 45, 90 triangle that has these side lengths. Cool, we know that. And what's another thing we've known for forever since geometry? SOHCAHTOA. And if we are talking about SOHCAHTOA and it's always these angles referenced to the x-axis, we know that the sine will always be dealing with the opposite side. The opposite side will always be the vertical. So that's another thing, kind of like I know that the sine being opposite over hypotenuse will always be the vertical over the hypotenuse. But since the hypotenuse is always 1, I just have to worry about the vertical. Because we're talking about a unit circle or these triangles with lengths of 1 everywhere. Cosine of an angle is adjacent over hypotenuse. But the adjacent side will always be this horizontal side or the x side. So it'll always be like the horizontal over 1. TOA, opposite over adjacent, will always be the vertical over the adjacent. So like, if you can just combine the stuff that you already know with some new stuff, radian measurements and reference angles to the x-axis and triangles that could have negative lengths, then we're good. Do you need help? Let me help you.
Yeah, I just need a quick question.
I gotta pause this video really quickly.
Sorry.
Cool, back at it. Helping in Geometry Kit. Where was I? Yeah, just like making these connections makes it easier for me. So, what is the sine of pi over 3? Well, I know that pi over 3 is 60 degrees. I know it creates this 60-degree triangle. Any pi over 3 will be a 60-degree triangle. We'll talk about that in a second when we get past the first quadrant. And I know sine's always opposite. And so opposite is always going to be this vertical length. And I just have to remember, okay, 60-degree triangle, tall triangle, there's a longer vertical side length and a shorter horizontal side length. So the sine is going to be that. Let me just put it down there so it's not in the way. What about the tangent of pi over 6? Okay, well, so pi over 6 creates the short 30, 60, 90 triangle. Here's the pi over 6 triangle. So I'm thinking about this triangle. That's 30 degrees. It's really the arc length is pi over 6, but we can see it creates this 30-degree angle that we're used to. And we know tangent is TOA. SOHCAHTOA. Opposite is going to be the vertical always. Adjacent is going to be the horizontal always. And you have a keep, change, flip situation, where dividing is the same as multiplying by the reciprocal. We talked about in class how this is acceptable on the AP exam on the free response portion. However, because of math history, we didn't have calculators. We talked about how rationalization was important to be able to get a decimal approximation for that. It's easier to divide a long decimal by a whole number versus a whole number divided by a decimal. Great. Well, what happens if we are outside? Well, here is where understanding adding angles and subtracting angles can help us tremendously. Where is 5 pi over 6? We talked about how it's not something that's memorized. Rather, we know where pi is. Pi is a halfway around the circle. It'll show up in a second. Okay, cool. We know that going around the circle in a counterclockwise method is adding. We know, therefore, that subtracting angles would be going in a clockwise method. Cool. I know that pi can be written in so many different ways that might be helpful. 3 pi over 3. Oh, 3 pi's over 3. 4 pi's over 4. 6 pi's over 6. Any pi's over that same amount. Well, that's helpful because look at 5 pi over 6. It is 1 less than 6 pi over 6. Well, I know pi over 6 is really the same as like 30 degrees. So if I go to 6 pi over 6 and then subtract a pi over 6, or if I go to 180 and subtract 30, I've made this 30-degree angle in the second quadrant. Okay, so this is new. We're out of the first quadrant. Yes, it's 150 degrees, but really what I care about is it's 30 degrees less than pi. Okay, great. So that's new. What also is new is not the triangle that's created with the x-axis, because we are familiar with this pi over 6 triangle. The pi over 6 triangle has a side length of 1/2 and a side length of root 3 over 2, the longer and the shorter. But what is new is the fact that, again, it's all about the trig of an angle equals the trig of the reference angle in the coordinate plane. The fact that we're going to the left, I'd consider this negative. This is how I work through that the sine of 5 pi over 6, since it's opposite over hypotenuse. Notice I did not label the hypotenuse of 1 because it's always going to be 1, and when you divide by 1, nothing changes. We're just going to deal with the opposite. The opposite is always the vertical length. Okay? This is the idea outside of the first quadrant, is you still have your triangles. Your triangles still exist. But pay attention to direction and make sure your triangle's in the right spot. Make sure you have the right triangle that you're thinking about. They're all right triangles. So like 4 pi over 3, I'm going to go to 3 pi over 3. I will then add a pi over 3. Now adding a pi over 3 is adding a 60-degree angle, which means I'm 60 degrees away from the x-axis. Now here is an important step. Don't make the triangle with the y-axis. Trigonometry is all about this reference angle and this triangle created with the x-axis. It's actually just one thing that we do have to memorize is like make it with the x-axis. No, I'm cooking. Let me cook. I know, and I'm cooking. All right, say hi. Say hi to Reed.
Is he gonna watch this?
I don't know.
If you watch this.
Yeah, cool. Cosine. Adjacent over hypotenuse. So katoa. Adjacent. Always x. X is negative 1/2 in this situation. Seven pi over 6. Where is it? What's the triangle? Well, it's 1 pi over 6 more than 6 pi over 6. Here's 6 pi over 6. Add a pi over 6. Pi over 6, 30 degrees. Think about 180 divided by 6. 30 degrees. Cool? So this is 30. This is the adjacent side length, which is the longer side length. This is the opposite side length. What do I have to pay attention to? The fact that they're both negative. So I'm considering this to be negative and this to be negative. The tangent opposite over adjacent, so that'd be negative 1/2 over negative root 3 over 2. Keep change flip. It's going to be negative 1 over root 3 or negative root 3 over 3. Okay? 11 pi over 6. Again, it's a pi over 6. So you could go to 6 pi over 6 and add 5 pi's over 6. Wouldn't it be easier if I went to 12 pi over 6, which is the same as 2 pi? Wouldn't it be easier to understand that I could subtract an angle? I will subtract a pi over 6 from 12 pi over 6. I get 11 pi over 6. It creates a 30-degree angle. I have this short 30, 60, 90 triangle. I don't really care about the vertical because it's cosine. Cosine, it deals with adjacents. Adjacents are always this x distance, this horizontal distance. 2 pi over 3. 1 pi over 3 less than 3 pi over 3. Here's pi. Here's 3 pi over 3. Subtract a pi over 3. 60-degree angle created. Tall 30, 60, 90 triangle. Yes, the adjacent is negative 1/2, but I just care about the opposite, and we are good. I got to go inside. I'm going to start to sweat. All right. I am in the testing room now because nobody's testing right now. Cool. 5 pi over 3 is 1 pi over 3 less than 6 pi over 3. What? What do you mean 6 pi over 3? Remember, if pi is, 3 pi over 3, 2 pi would be 6 pi over 3. It'd be 12 pi over 6. Just things to remember. So, the tangent of 5 pi over 3. Let's start with where is 5 pi over 3? It's 1 pi over 3 less than 6 pi over 3. 6 pi over 3 is all the way over here at 2 pi. Subtract 60 degrees. Be exaggerated. Know that this has to be the short side, this has to be the long side. Tangent, opposite, always vertical. Adjacent, always horizontal. Negative root 3. Secant 5 pi over 3. All right, this is a reciprocal function. What is a reciprocal function? It's just a flip of the fraction that we get. So we're going to get an answer, a ratio, and we're just going to flip it. Like secant would be hypotenuse over adjacent, or 1 over the adjacent side, the x-axis side. We already have our triangle, so I'm just going to go over here, and I'm going to say secant is the reciprocal of cosine. I already know cosine's a half, so I'm going to take the cosine of 5 pi over 3, which is a half, and I'm going to flip it to get 2. 4 pi over 3. It's like I should be good at this, and you should maybe start getting to be like, oh, I can do this in my head. Maybe. If not, just keep practicing this way. What we don't want to is just give up and just revert back to, I'm just going to copy down the unit circle. It's like, it'll work. It'll work. I don't want to hate if you do that. But if it's not going to stay with you, then I don't want you to do it. 4 pi over 3 is pi plus pi over 3. Pi over 3, 60-degree angle, tall, 30, 60, 90. Cosecant, reciprocal of sine. Sine is always opposite. It's always the vertical. Vertical is negative root 3 over 2, or flipped that, times root 3 over 3, negative 2 root 3 over 3. Great. Cotangent, I like to not do tangent and then flip it. I know that tangent of an angle is the opposite over the adjacent. So that means cotangent is going to be the adjacent over the opposite. I find it's just a little bit more efficient if I do that. So I'm going to find the adjacent over the opposite of 7 pi over 6. 7 pi over 6 is 1 pi over 6 more than 6 pi over 6. Here is 6 pi over 6, which is the same as pi. I will add a pi over 6, 30 degrees. Here is my triangle that I know. And that triangle is negative root 3 over 2 and negative a half. Adjacent over opposite would be negative root 3 over 2 over negative a half, which ends up being positive root 3. Cool. Good start. What happens if we don't see a triangle? We talked about it in class. How? What about like at 0? I don't see a triangle, Mr. Mester. How can you do SOHCAHTOA if no triangle exists? Well, it does. This is where things might go a little bit off the rails, and I don't want you to be confused. This is where I might say, guys, remember how sine is always opposite, which is always vertical, which is always y. Cosine, which is always adjacent, which is always the horizontal, which is always x. This is the time where I'm okay if you're like, oh yeah, x versus y. Coordinate versus what coordinate? Because I showed you in class, you could be like, oh yeah, there is a triangle. It's just like a very exaggerated form of this triangle where the hypotenuse always 1. But this adjacent side length is going to be the same length as the hypotenuse, and we have no vertical length. Now, if you think about it, like if you have an angle here, opposite 0 over hypotenuse, 1, 0 over 1. Oh yeah, that's 0. Cosine of 0. Oh, well, the adjacent over 1. Oh, that's 1. But if that is a little bit weirdly created and you don't really get why this actually is like this, maybe you go with the fact that you're going to the right one and you're not going up or down at all. Maybe you go to the fact that this point on the unit circle is the point 1, 0, and the y versus the x. This is where I'm actually like, okay. Because like at pi over 2, here, the triangle created, let's see if you can think about it. You're not having any x distance. So it's like we have this x distance of 0, the y distance of 1, and the hypotenuse of 1. That's one way you could say 1. You could say, oh, it's the vertical length. I'm going up 1. I'm not going to the left or to the right at all. Maybe that's what you could do. Maybe you go 0, 1. Maybe. Cosine of 3 pi over 2. What is 3 pi over 2? And I forgot about pi over 2. What is pi over 2? We'll think about if pi is 180. Pi divided by 2 is 90, which means pi plus pi over 2. Oh, now it's 2 pi over 2 plus pi over 2, 3 pi over 2. So that's 90 degrees more than pi, or 90 degrees less than 2 pi. Here, same deal. There's no left or right. We are going down. Maybe you have that in mind. Maybe you have horizontal versus vertical. I'm going down, that's 0. Maybe you go to the point 0, -1. This is where I'm okay with this. So that's 0. That is opposite over adjacent. Opposite over adjacent. Y over x. I would want you to put that. And then, why is that undefined? Is it undefined? Let's remember, this is how I remember that this is undefined. What is 8 divided by 2? 4. Why? Because 2 times 4 is 8. Is this 0? Well, if it was, just like 2 times 4 is 8, then 0 times 0 is 1. That is not true. So this is false. This is why we say this is undefined. If I flip it, is this true? Is 1 times 0, 0? Yes. So like always start with just something you know versus memorizing. Again, I'm horrible at memory. I think that makes me a good math teacher because let's try to memorize less and understand more. All right, now we switch over to what students consider are the tougher stuff, going backwards. Here we have the trig function. We don't know the angle, we do know the ratio. We are trying to find all of our solutions from 0 to 2 pi. So we're trying to find all of our angles from 0 to 2 pi, where the cosine of the angle equals 1/2. Oh, what do we do here? Well, I still go back to my triangles. My tall 30, 60, 90 triangle created by pi over 3 radian with this opposite and this adjacent. I go to my short 30, 60, 90 triangle where the 30-degree angle is the reference angle, where we have at the pi over 6's, because pi divided by 6 is 30. And I got this as 1/2, and this is root 3 over 2. And then I have my 45, 45, 90, which is at the pi over 4's, which is 45 degrees. And that's root 2 over 2 and root 2 over 2. Okay? I always start with the triangles. That's honestly the things that I have remembered since geometry, the special like x, root 3x, 2x kind of deal. But then I just switched over to like 1/2, root 3 over 2, 1. Okay. Here's what we do. We know that cosine deals with adjacents, deals with horizontal. Which of these 3 triangles has an adjacent or a horizontal that equals 1/2? This triangle creates that. Cool. The last thing we have to worry about is when is cosine positive. Cosine is positive in the first quadrant, where all trig functions are positive, and the fourth quadrant, where all of the angles here will have a positive adjacent. This is all students take calculus. It helps you understand which angles are positive where. or which trig functions give you positive solutions where. So what I do is I realize, oh, I want the pi over 3 triangles in these two quadrants. You can either draw them or just like reference the two quadrants and be like, what are the pi over 3's there? Well, this angle would be 1 pi over 3. This angle would be negative pi over 3. You could consider that if you start at 0 and subtract. Or you could go all the way around to 2 pi and subtract a pi over 3 to get 5 pi over 3. Or you go to 3 pi over 3, add 60 degrees twice to get 5 pi over 3. I like to go to 6 pi over 3 and subtract a pi over 3. Okay, now we go to this situation. Sine of an angle equals negative a half. Well, I'm going to go to the triangle. Okay, when is the opposite or the vertical going to be a half? This triangle, the pi over 6 triangle, has the opposite that's a half. Cool. Where is sine negative? Sine is negative in the third and fourth quadrants, which means I want those pi over 6 triangles in the third and the fourth quadrant. You can either go straight off of this and be like, what is the pi over 6 here? Well, it's got to be 1 pi over 6 away from 6 pi over 6. What is the pi over 6 here? It's 1 pi over 6 less than 12 pi over 6. Maybe you do that. Maybe you draw the pi over 6 here and draw the pi over 6 here, and you think about, okay, it's like 180 plus 30 or pi plus pi over 6. That's how we're going to get 7 pi over 6 and 11 pi over 6. Cool? Which triangle will the adjacent be root 3 over 2? Oh, it's back to the pi over 6. So I'm going to be like pi over 6, pi over 6. This is the key. Which quadrant is cosine negative? All students take calculus. Oh, this quadrant. I want the pi over 6 here, and I want the pi over 6 here. So start with pi, subtract a pi over 6, add a pi over 6. We get 5 pi over 6 and 7 pi over 6. If you understand your triangles and you understand how to move around to find radians, this is really the same as day one. Okay? So just use your triangles to help you. What about this situation? Well, again, you could think about cosines being adjacent or the horizontal, and you could think, when will my horizontal length be 0? And you can think about, okay, so I don't want to go to the right or to the left at all, that horizontal. I want to just go up and down. You could think, I want my x coordinate to be 0. Different things to do there. Sine opposite vertical root 3 over 2. Back to this pi over 3 triangle. Okay, when is sine positive? In the first and the second quadrant. I want the pi over 3's in the first and second quadrants. When is my adjacent, which is always my horizontal in the unit circle, going to be this -1? When will I move to the left 1? Oh, it's got to be at pi. Did not get to this in the first class. Might not have gotten to in the second. Haven't taught it yet. What if you have sine equaling cosine? Well, you can think about it, or you can divide both sides by cosine. When does tangent equal 1? Now, I have not included many answers that dealt with the pi over 4s because the pi over 4 triangles are the easier triangles to deal with. I assume you understand that the pi over 4 is a 45, 45, 90 isosceles right triangle. So, tangent equaling 1 has to be at the 45, 45, 90 triangles. But it's not just here, because tangent is also positive here. We want the pi over 4 here and here. Now, let's think about what is the pi over 4 in the third quadrant. Use the same thought process of, I know where pi is, I know what adding is. Adding is going around in this direction. Subtracting is going around in this direction. So, if this is pi, I want to add a pi over 4 to get my 5 pi over 4. When will my vertical length be 0? Obviously, if I'm here or here, I'm not going up or down at all. I have this triangle with like 1, 0, 1 if we want to. This is going to be at 0 and at pi and at 2 pi. If we're talking about 0 and 2 pi, all of those angles, then that's it. Do the same thing as what we did before. And I'll get tangent equaling -1. Okay, that's going to be at the pi over 4 triangle because of the opposite over the adjacent equaling 1. So I want the pi over 4s when tangent is negative here and here. How do I get that pi over 4? 4 pi over 4 minus a pi over 4, 3 pi over 4. 8 pi over 4 minus a pi over 4, 7 pi over 4. Opposite over adjacent. Y over X. Vertical over horizontal. I need that to be 0 and that to be plus or minus 1. Because remember, 0 over 1 equals 0 makes sense. 1 times 0 is 0. So I want the vertical to be 0. I want the horizontal to be 1. The vertical to be 0. The horizontal to be 1. The opposite, the vertical, is -1. Where will the vertical be -1? 3 pi over 2. Oh, look at that. Try this one on your own. The answer is 2 pi over 3 and 4 pi over 3. See if you can get that without the explanation. And then the last thing is just like, what happens if we have more than just like cosine x, cosine pi? And what if I ask you for all solutions? Okay, there's two things we're going to do. Let's first start with, what if this was just an angle? Cool. Work through yourself why the angles are 2 pi over 3 and 4 pi over 3. We did this earlier. Great. Now, what do you mean, Mr. Messner? You are not confined to 0 to 2 pi. Well, 2 pi over 3 creates this 60-degree angle. 60-degree angle creates this triangle. Is there any other possible angles that create this 60-degree angle with the x-axis? And the answer is yes, there's infinite. Because we can always go around the circle in any direction, end up where we started or where we came from, and still create this 60-degree angle with the x-axis. This is the concept of like adding 2 pi or subtracting 2 pi or adding 4 pi or adding any amount of 2 pi, any multiple of 2 pi to get more possible answers. These are called coterminal angles. They are ending up in the same location, but they are different angles. So we have to understand that, yes, these are two solutions, but any multiple of 2 pi, adding and subtracting, works. This is why we break out this this like 2 pi k. It's like k. What is k? Well, if k is an integer, then adding or subtracting an amount of 2 pi's will get you back to the same location. Okay, that's the first thing. The second thing is, well, it's not cosine of theta, Mr. Master. You're right. It's not cosine of theta. It's the cosine of pi x over 2. Pi x over 2 represents my angles. This is my angles equaling this. Well, we need to find the solutions for x, which means we got to somehow get rid of this pi and this 2. Well, this is where we will think about just like solving. Multiply everything by 2 over pi. Well, if I multiply this by 2 over pi, the pi's will cancel. This becomes 4/3. If I multiply this by 2 over pi, the pi's cancel. This becomes 8/3. Okay, those are my two numbers. Times pi over 2 becomes solutions. Multiplying this by 2 over pi, pi's canceling, becomes 4k. This is what we're looking for the answer. We start with our angles, understand our coterminal angles, the whole 2 pi k, but then manipulate our angle to find our solutions. So sine of an angle equals 0. What are our angles? My angles are 0 and pi and 2 pi and multiples of 2 pi. So I can really just start with this. You can actually understand that you could just have pi k, but let's just keep it simple. Let's just start with this because you're correct, and I don't want you to freak out about semantics. But it's not my angles here that I'm trying to find. I'm trying to find x. So I understand x over 4 represents my angles. My angles are this x over 4, and I want to find my solutions by multiplying everything by 4. That's fine. There are other things to do. Cosine equaling 0. Adjacent equaling 0. Adjacent equals 0. I'm not going to go to the right or the left or any at all. I'm going to go up and down. My angles are pi over 2 and 3 pi over 2 and multiples of 2 pi added or subtracted to that. But my solutions will come from dividing all of these by 2 pi. Now, what is pi over 2 divided by 2 pi? Well, the pi's will cancel, and it's the same as like multiplying by 1 over 2 pi. This will be a fourth. This will be 3/4. This will just be integers. Okay, a couple more. Maybe we need to be prepared to solve for the trig function before finding our angles and then our solutions. My angles will have to be when is sine opposite equal to a half, opposite half. That's got to be the pi over 6 triangle where the opposite is a half. Pi over 6, sine is positive here and here. I want the pi over 6's here and here because they will create the 30-degree triangles. The pi over 6's there and there are going to be 1 pi over 6. Okay, this is 6 pi over 6 minus a pi over 6, or 5 pi over 6. And multiples of 2 pi added to those two numbers. There's a pi over 6 and a 5 pi over 6. I am sorry for being messy. Honestly, this is why I don't like doing keys, because nobody's going to be able to read my key. I will multiply by 4. I will divide by pi to get x. My solutions. 4 over 6, the pi's cancel, are 2/3. 20 over 6 is 10/3. 8 multiples of 8. Cool. All right, finish strong. Add 3. Tangent equaling -1. Think about the triangle. Which is the triangle? Tangents equal to -1. Well, that's when the opposite over the adjacent's the same. We're going to have the pi over 4. I'm thinking about the pi over 4's. I'm thinking about the pi over 4 where tangent's negative. Tangent's going to be negative there and there. So I want the pi over 4 there. I want the pi over 4 there. 4 pi over 4 minus a pi over 4. 3 pi over 4. These are my angles equal to 3 pi over 4. 8 pi over 4 minus pi over 4. 7 pi over 4 plus multiples of 2 pi. Times 2 divide by 3 pi everywhere you see. Giving your solutions. Times 2 divided by 3 pi. So 2, that's 6/12, or this is cancel the 2's, cancel the 3 pi's, 1/2. 14/12, or cancel the 2, that's a 2. 7/6, right? 2, that's a 2. 2 times 3 is 6, 7/6. Plus 4/3 added to these, subtracted from these, multiples of 4/3. And yeah, we're good. The angle where cosine is 1 is 0 and 2 pi. So pi theta 6 equals 0 or 2 pi. And multiples of 2 pi, which means you're really just like talking about multiples of 2 pi, but whatever, let's start with that. Multiply by 6, divide by pi. That gives me 12 plus multiples of 12. Think about this, 12 plus multiples of 12. It's really just multiples of 12. But this is fine. This is totally cool. Yo, it will help you tremendously if you have this understood. We are looking in this class to memorize less and understand more. If you try to memorize everything for the AP test at the end of the year, it's too much. This is a cumulative class. Let's try to make it as easy as possible on ourselves. So, what's our goal? Memorize less, understand more, tie things together as much as possible, and we will make it easier on ourselves, okay? Hope you enjoyed this video. I will see you out there. Peace.